Hey everybody, this sensor can generate electricity with no battery connected to it. This ignition coil can generate over 30,000 volts from a 12 volt system. How do they do that? Well, it's a matter of physics. And these two parts and many other parts on an automobile work off of the same principle of physics. So let's understand how they work. Okay, so let's start out by looking at that vehicle speed sensor and how it works. So this is just a generic vehicle speed sensor. It's actually off a 2002 Oldsmobile Alero. And if you look right there inside the connector housing, you'll see two terminals. So within this, right in the very center of this, is a magnet, a permanent magnet. And then wound around that magnet is hundreds of windings of very fine copper wire. On both ends of the wire, of the copper wire, that's what we're seeing right here. So, of course, a magnet has an invisible magnetic field. That magnetic field is going to keep the electrons in that wire, in the wire windings, holding steady. So they're really not doing anything at this point, but just sitting there ready to do something. So what I'm going to do is I'm going to connect two terminals to this vehicle speed sensor. And I'm going to connect that to an oscilloscope. Now this oscilloscope is available on Amazon. It's a good, works well for me, oscilloscope. And I will have a link to this oscilloscope below. It's a handheld oscilloscope and it's a 2-channel. Okay, so what I'm doing here, and I'm sorry that I couldn't show you what I was doing, but I have connected the two wires to my vehicle speed sensor. So I'm going to use this screwdriver to go back and forth across the bottom. Hold this up where you can see it, the bottom of this sensor, and you can see that we're actually generating a voltage. Every time I go back and forth across the bottom of this wheel speed sensor, I'm actually generating a voltage. So how, when I have nothing hooked to it except the oscilloscope, how am I generating a voltage by doing what I just did? How it works is every time this screwdriver would go across the magnet, it was breaking the magnetic field, making the electrons move. And let me pull this back up again. As you look at the scope image, the yellow line right here is our 0 line. So you can see that we're going back and forth across. So we actually have voltage coming and going. The reason why is the polarity is reversing depending on which side of the magnet I go on. So that is what kind of voltage am I generating? Okay, that's an AC, an alternating current voltage, because voltage is reversing polarity. So ECMs, electronic control modules, that would receive this signal work off of DC voltage. So inside the ECM, there is a converter that will convert the AC to a readable or usable DC for it. So that's how this works. In reality, there's a reluctor wheel, which is a metal wheel with a bunch of teeth on it, that as the car is going down the road, that wheel will go, the wheel will turn and the teeth will go by this. The faster you go, the quicker the teeth go, the more oscillations the ECM sees, and thereby it knows how fast you're going because of that. So that is how a vehicle speed sensor works and generates voltage without a battery. It's a matter of physics and magnetism, magnetic inductance, causing electrons to flow. So that's how the vehicle speed sensor works. But let's take a look at this ignition coil. So the ignition coil generates a ton of voltage, and it does operate off of the same theory of magnetic inductance. However, this has two different sets of windings, and there is no permanent magnet inside an ignition coil. Now, this ignition coil is off of a Trailblazer. Don't remember what year. Chevrolet Trailblazer. Let's take a close look at the inside of this thing. So I've got one that I actually had cut in half so that we can take a look at it in a little closer detail. So inside the ignition coil, you'll see a couple different things. First is an iron core, right here in the very center. And then wound around that iron core is really fine winding. So usually 100 or more, sometimes hundreds of windings of wire just wound around that iron core. So that's the secondary windings. And then the primary windings are these bigger windings that you see on the side right here. So it's a much bigger, thicker wire. And those are the primary windings. So the primary windings are wrapped around the secondary windings. And then we have the iron core. And as you can see, that iron core leads to what would be a spark plug wire or some sort of connection directly to the spark plug. So what happens if we take a piece of iron and we wrap wires around it and then we electrify it? Like, let's just say in the case of this, we put 12 volts to this coil and with a ground. What happens to that? Right. We create an electromagnet. Most of us, when we were kids in elementary school, made electromagnets with a nail, some wire, probably a 9-volt battery, and then we picked up paper clips with it because we just created an electromagnet. Well, on this system, the primary windings, the bigger windings, are what we're going to electrify. So we're going to have 12 volts to the system. The ECM is going to ground the coil, creating an electromagnet. So that electromagnet is now surrounding the outside of the coil, right? So just imagine the electromagnet, the lines of magnetic force around the outside of the coil. Then when the ECM cuts power to it, that magnetic field is going to collapse, and that actually induces a voltage into the secondary windings, which creates spark. And because we have such a difference in gauge of wire between the primary and the secondary windings and the number of windings, we now have pretty much a step-up transformer. So we're stepping up 12 volts from 12 volts to upwards of 25 or 30,000 volts even, just due to that magnetic field collapsing into the secondary windings. And that's how it works. Okay, so now that we know how the vehicle speed sensor works, how an ignition coil works, let's talk about how to diagnose these systems. And now that you have a better understanding of how magnetic inductance works, how we can generate a voltage without using a battery to power anything, and how we can increase voltage as well by having two windings wound around each other, how we can multiply voltage by a lot. So let's talk about diagnosing now. So let's say that you've got a vehicle that has a issue with the analog brake system, or the vehicle speed sensor is or the speedometer is just erratic. So, Bill, how do we test that? Well, number one, I'm jumping on a scan tool and I'm going to look at the vehicle speed sensor data to see if it looks feasible. So, like if I feel like I'm running 50 miles an hour and the speedometer or the scan tool is showing me 10 miles an hour or 100 miles an hour, or it's just going absolutely nuts when I'm at a steady speed, then that's a pretty good clue something's wrong. However, it's not always that simple. Sometimes we can have one tooth on that reluctor wheel that's chipped, or there could be foreign material in between the teeth, or sometimes even that reluctor wheel, I've seen this, on the output shaft of a transmission can actually walk backwards or forwards, and that's going to change the signal as well. So then how can we pick up on that? Well, I'm going to switch to my notepad here, and I'm going to draw some really crappy drawings, but hopefully it will help you understand what to look for with an oscilloscope. And again, the oscilloscope that I'm using is a O1, I don't know how you pronounce this, OWON HDS 272S. You can get them on Amazon or pretty much anywhere. But you can spend as much or as little as you want on an oscilloscope. But what I'm going to do is I'm going to hook an oscilloscope up, because even if I hook a voltmeter up to this, yes, it's going to generate a voltage for me, but just generating a voltage isn't going to help me understand where the issue is. Is it in the sensor, or is it something with the reluctor? Now, if it's not able to generate a voltage, then I'm going to say we probably do have a bad vehicle speed sensor. In that case, what I do is get an ohm meter and just ohm between the two terminals in here to see if we have an open winding or high resistance, compare it to whatever service information says. But with an oscilloscope, and again, you can get really inexpensive oscilloscopes now, I'm going to hook an oscilloscope to this, and the pattern I'm looking for, depending on the speed, is something very similar to this. Okay, with this being our zero line, we're wanting to see voltage, positive voltage and negative voltage, and it's not really negative voltage, it's that it's reversing polarity, but that's the way it shows it on an oscilloscope. So we're just seeing the polarity reverse back and forth, back and forth. That's what we should see. Now, if you get a pattern that looks something like this, then we've got a problem. This is an indicator of a reluctor tooth that's got an issue. The other thing is, this pattern the faster you go, the taller the pattern is going to be, and the closer together it's going to be as well. So possibly, if the pattern looks good, what I would do is compare it to either another vehicle or a vehicle speed sensor on the other side of the vehicle, and see if the I can't remember the term, to see if the height of the pattern is the same, and the width, how close together the patterns are or how far apart they are the same. If they're different, then it could be that your reluctor has shifted, or that this is not mounted properly and it's not close enough to that reluctor wheel. Believe it or not, these do have to be really close to the reluctor wheel, and the further away you move it from the reluctor, rust, dirt, grease, whatever, the further away you move it from the reluctor, the weaker that signal is going to be, and that will fool the ECM or EBCM into thinking that you have a problem. So let's look at an ignition coil. Now, back when I first started as a tech, we had And some of you older people out there will remember this. We had a big old sun scope. It was one of the first oscilloscopes for vehicles in the aftermarket or the commercial market that there really was. And this thing, you would hook it up to the ignition coil and also to a spark plug wire, and you could actually see the pattern of each spark plug as it fired, and see the pattern of the ignition coil as it fired. And again, forgive my drawing skills for this, because this is a lot more complicated. So it would look something like this, as we would just kind of have a flat line. So this line is the ignition coil, the electromagnetic field being built up. So it's turned on now. The electromagnetic field is building. Then we turn off power to the ignition coil, and bam, we'll see a large spike of magnetic voltage inductance. So we'll see a large voltage spike, and we'll just call it 15K just for the sake of this video. So 15,000 volts, okay? And then very quickly, it's going to drop back down as it jumps across the spark plug, and then you'll see some oscillations, and we'll be right back to building that magnetic field. That's what an ignition oscilloscope pattern should look like-ish. So if you have a pattern that instead of going straight up and almost straight down and then having this little spark plug gap right here, if it does something like this, then you've got a spark plug that's closed up. It's oil fouled or whatever the case may be. If you've got if you're seeing all the cylinders at once on the oscilloscope, and you can do that easily, it's hard for me to draw it on here. But if you've got one that the kilovolts is really high, then you've got a problem with that cylinder. It could be the spark plug gap is too wide. It could be the electrode is worn out. There's a lot of things that indicate that. But basically what we're doing is we're comparing one cylinder to the next with the oscilloscope pattern. And the main thing is I wanted to show y'all how when the magnetic field collapses, it creates that huge voltage spike that is then able to jump across the spark plug gap with all of the pressure that's inside that cylinder. So it does take this much voltage because there's a lot of pressure in that cylinder as it's coming up on the power stroke, the compression stroke, to overcome. So where else in a vehicle might an electromagnet be? Well, ignition coil, we just did ignition coils, Bill. The relays in a vehicle work off of the principle of being an electromagnet. Another thing is in a fuel injector. When a fuel injector is turned on, again, how it lifts the pencil to allow fuel to squirt into the cylinder is by using electromagnetism. So it's going to be an electromagnet. It's going to raise up, squirt fuel. When the ECM cuts voltage to it, you will see a voltage spike to about 60 volts or so, depending on the make and model of the vehicle. It varies. But you'll see a voltage spike there as well. Because again, the magnetic field is collapsing and it's inducing voltage into the wires. So magnetic induction is really cool. That's how brushless motors work in vehicles. EVs use brushless motors. A lot of HVAC blower motors are now brushless motors. And that's how they work, is just magnetic inductance. So I hope I taught you something today. It's been a fun video for me. It was really cool to have our machine tool department at work cut this coil in half so that I could show you what the inside looks like. I really enjoyed watching that process. And if you enjoyed the video, be sure you hit a like and subscribe. I appreciate it. Also, be sure you check out, I wrote a 365-day devotional for technicians. If you're interested in that sort of thing, just a little meditation time each morning before you get going. The lessons are not even lessons, just the reading is 5 minutes or less, maybe a little more each day, just a one pager. It is on Amazon, and I will link it below. Until then, until I see you next time, God bless y'all. Take care. See you next time.